Hello everyone, we are Virtual Engineering and this is Electroverse. We are in the three-phase circuits laboratory. In this video, we are going to measure the power dissipated in the resistors, which will be connected to 4 wires. We will use 3 wattmeters. So let's get started. I'm just going to go ahead and grab those digital wattmeters now. Let's put them here. Move this one over here and this one more to the middle. And for those of you who don't know how to connect the wattmeter yet, there's a video that Virtual Engineering made about connecting it in a single-phase circuit. About a wattmeter in a single-phase circuit, and it can help with your learning. Here we're already going to make the connection. Okay, I'll draw it here so we'll have our power source. Now let's carefully connect the first wattmeter to the circuit, and then we will proceed to set up another wattmeter in the same manner to complete the measurement setup. We will now introduce an additional wattmeter unit. Here, it will be properly grounded. Here. Take the 250 ohm resistors. Now, let's place them into the board, and then we can proceed with the injection process. 100 volts 3-phase. So here's the 100 volt connection, phase to neutral. Here we will close the circuit at the power source. There's a terminal there for that purpose. And the wattmeters, folks, they need to be connected. They need to be in series. They measure current, and now we need to provide them with a voltage reference. So we are going to always connect the wattmeters to the ground reference. So that's what we're going to do now. All right, everyone, so let's get started. Now for phase C, I am specifically planning on using this bright red colored cable. I'll connect it to make the first series connection. All right, I'll connect all the connections first, seriously. So here the white one. And the blue one. All right, now let's move on and start to make the closures for this project. I'm going to use a black cable. And this connection I think I am going to take the much more straightforward and simpler path and just bring everything to a final conclusion right here. Done. And now I'm going to make the parallel connections. I'll make the parallel connections starting with the red one. I am now going to carefully connect this device. And then, guys, I will be able to pick up a very strong potential signal right here. This way, I can easily pick up a potential right here on my IA plus device. It doesn't really matter whether it is plus or minus. I'm carefully taking this potential to reference my positive terminal. And now I'm going to reach over and get another one, which is the other cable I need. I'll take the black one. And then after that, I will carefully connect it directly to the neutral wire. So here in this spot, here guys, is neutral. I've connected the first watt meter, now I'll do the same for the others. I'll take a white cable. Take my positive voltage reference. And I'll pick up a bright standard blue cable. And now I'll set up and configure the precise voltage reference point right here. If I have a neutral cable, here, I'll take the neutral from here, guys, and connect it here. And I'll take it right over here. And I'll put it here. So that's it, guys. I've referenced everything, made all the connections, so now we just need to start the simulation. I have 250 ohms. I'm going to apply 100 volts. What will my power be? For my power, it's going to be the voltage squared over the resistor. I only have V squared over Z, which will be equal to 100 volts. Squared over 250. So here it is, which is the same as 1000 divided by 25. 1000 divided by 25 will give number 4, that makes it 40. So I'll have 40 watts. So let's go ahead and get started. Alright, so right now I am going to start the process of injecting 3265 and we will see how it goes. $102. I have successfully matched all of the phases, and now guys, let's take a closer look at the readings here. I have exactly 102 volts and a measurement of 41.74 watts being produced in each individual phase. So guys, what does it mean? That the total dissipated three-phase power is the sum of these 3 times 41, which will give 123. And I'm not counting the decimal places here, just the whole part. So 123 watts total power dissipated in this circuit. Well guys, that's all I had to say in this video. We made the connections for all 3 phases, calculated the power dissipated across the resistors. And that's it, folks. Take care and see you next time.